Hello. So now we're moving on to section 3.4, which is divergence and integral tests. This one is less logical thinking. It's more like using proven stuff. So will probably be a little bit easier than 3.3. But more importantly, I brought something tantalizing. Something to keep me at my desk. It's a goddamn collar. There we go. It's so weird. Now I just need someone to hook it like this with this leash I have. That's a fun sound. You wanna hold this leash? Keep me at my desk while I finish this work. I'm just kidding. There's no way I can do work with this collar on. Sorry, but I'm saving you for the bed. What were we saying? Right, section 3.4. You can hear that, right? I'm gonna move the microphone closer just in case. Determine if it converges or diverges. Using divergence or integral test. Okay. Squared plus 2. Okay. This one doesn't seem to be decreasing. So the integral test will fail, which means that it's divergence test. Divergence test is if the limit of the sequence is convergent, then yeah. If the limit of the sequence is not 0, that means it's divergent. Okay, that makes sense. For this one, I'm going to use L'Hopital's rule twice. L'Hopital's is fun because if you have a limit that if you were to evaluate it and you would get something that looks like infinity over infinity or 0 over 0, you're able to take the derivative of top and the bottom. I mean, like the denominator and the numerator. My pencil's out of lead. I hate it when that happens. Are you fucking... Oh, okay. Thank goodness. Thought I was totally out of lead. But I'm not. This is a fun sound. It's over here. may have to go out and buy more 0.5% lead. I seem to be running low. Didn't run completely out, but we are running out. What's this other condition? Oh, right. Continuous. Yes, over 1 to infinity. And the third one, is it decreasing? That one I can see visually, yes, but it is a little difficult to prove because I need to find the derivative. Yeah, let f of x ln of x over x, and then f prime of x equals this part I don't like. I don't think it's that bad though. It's just something over x squared. X times 1 over x. Hey, that becomes 1. Minus ln of x times 1. Oh, is that negative after all? I need to look at when ln of x is greater than 1. Then we're good. I need to move on to a different piece of paper. Right. So ln of x has to be greater than 1. That means x needs to be greater than e to the first power, which is what do we have in our notes of functions that are only decreasing at a certain point? Oh, so it just applies the same way. You don't have to worry about it. So, third condition, if it's decreasing, f of x is decreasing from e to infinity. Or e isn't included. Because then it's just 0, and that's not negative. I'm so silly. ln of 1 is 0, and that's not positive. I'm so silly. So it fails the integral test and the derivative test. Oh no, what now? I do remember doing this one in class, I swear. I just must have not written it down, which is very unlike me. I'm concerned. Does that mean we just don't know? Maybe? This is a problem again. Sum of n equals 1 of ln of n over n. There must be a trick for this. This one is similar, but not the same. Big yawn. So that just means that it's not possible. It's inconclusive. I got to see what this graph looks like. ln x over x. Huh. That's weird. Or some, we just don't know if it converges or diverges. Or, I suppose, it hasn't been discovered yet. That's the more exciting way to think about it. Maybe I could be the person to prove that it, in fact, does converge or diverge. Just maybe in a few years. You know, we have a bunch of stuff for proving if it's converging or diverging. I don't believe we have anything for proving that it doesn't converge or diverge. Like, neither are possible. I wonder if that exists. This one, I know you converge just by looking at you. But I have to go through the steps of the integral test. Positive. Because the top is always 1, and the bottom is something to the 6th power, which is always positive. Is it frick. Positive, decreasing, continuous. Yes. Last one, decreasing. Let's let f of x be equal to 1 over 8x plus 3 to the 6th power, and let's find f prime of x. 8x plus 3 to the, what is that, 8th power? Goodness. Or no, it would be the 12th power, wouldn't it? So many. That one will just go away. So you would have a negative of whatever that is. I don't want to think about what the integral of that is. Or rather, the derivative. I'm such a silly. So the integral test applies. Fantastic. Surely there must be a faster way to do this. I don't know, but doing it the long way is good practice, I hope. Oh no, my poster's falling down. That was really convenient timing. I just started recording. I'll fix it later. I'm getting faster at these. Off the bat, so integral test needed. Forgot to start my music. Hey, I recognize you. You're arctangent. Pattern recognition. It helps. here. 9 limits equals to infinity. Arctan A minus tan of 1. I believe that's pi over 4. But I'm gonna double check. I'm right. What a relief. So our answer is pi over 4. 9 pi over 4, rather. I'm going to rewrite you as 5n over e to the n. Is that one? Oh, it starts at 3. That's interesting. That probably means integral test, but divergence test, would that work? No, that would still give 0. I should use all of my colors. I have a lot of pens, and I love all of them. Three to infinity. Yes. What about positive? 3 to infinity. Decreasing. Integral test is, I mean, it's the most comprehensive test that we have. And because of that, it also takes a lot of time. So it's a little bit lengthy to go through the processes, but it's pretty strong. I just wish it were a bit faster. There are faster methods coming up, but this is what's for this chapter, so you can't go using a root test and stuff like this. That wouldn't make any sense. And you don't know what that is, but that's okay. Or maybe you do, smart pup, or kitty, or whatever you are. can see how this is going to get messy. Okay, x has to be greater than 1. That's why we didn't start at 1, so this would work. I see what you're doing. And now we can do x goes to infinity. No, a goes to infinity. 3a. Break my lid. 5x over e to the x. dx. X over e to the x. Is that integrable? It might be like a tricky haha question, but it's probably integrable. Oh, it's just integration by parts. I don't like integration by parts. I did good on it at the last test, though, so there's that. Why so much? E to the x. Okay. Evaluated it. A and 3. Minus a plus 1 e to the a minus 3 plus 1 e to the 3. What does that equal? Okay, well, that one is L'Hopital's. So it would be negative 10 over e to the 3 power. That was a tough one. Curious if that's even right. Well, it converges. That falls in line with what I said. Up next. Oh no. Am I gonna spend an entire sheet of paper? No. I'm gonna use half a sheet of paper on this one problem. I'm so glad I thought ahead. Can we use the integral test to determine if it's convergent or divergent? So we have cosine pi n over n to the 8th root. Integral test. So it would need to be continuous. It would need to be always positive. Well, the bottom part would be always positive. So that means if this top part could be negative, then the entire thing becomes negative, and it doesn't work with the integral test. which it can be. I think that's a good enough explanation. Okay. That's another section. Complete. My notes are always, or my homework rather, is always very colorful because you use a bunch of different colored pens to make it all fun. Next chapter to be conquered. Section 3.5. Comparison tests are... comparison tests are bad. You have to pick a number and just get lucky. Or not a number, but a series, a function. And if your series, like, there's some aspects of that series that you pick that need to happen in order for it to even help with the problem. So they're not easy, not quick, rather. So I actually think I'm going to move to section 3.6, just because I need the productivity boost. Alternating series tests. These ones are pretty simple. Those are the ones that I had to take notes on because I was absent. I'm looking forward to section 3.7 the most, though, because that's ratio and root tests, and those are very clean, very easy. I love them. Number 1. Determine if it converges or diverges. I'm noticing a trend. Well, it's certainly not harmonics. This is a good candidate for the alternating series test. However, we need a function or a series to do that, and I only have the first few parts of that series, which are not the same thing. I need to create a series for this, which I can then use on the alternating series test. But the sequence is negative 2/5, positive 7 over 11, negative 6, negative 5, oh my god, negative 5 over 6, plus 1, and then negative 8 over 7. That is completely disgusting. Although, I think I figured it out. That 1 may in fact be something like 11 over 11. What does that give me? They wouldn't give a question with a piecewise at the very start. No, they wouldn't. That would be so evil. Would be pretty funny though. You know, I'm going to go get a drink. I will be right back. Not alcoholic. I mean like protein shake. Alright. So, I recognized that the first 3 terms are all less than 1. Or their ratio, or the absolute value of them is less than 1. And this one, a sub n equals 1. And on this one, I should use a warmer color. This one. The absolute value of a sub n is greater than 1. What does that mean? Certainly doesn't help with our alternating series test. The ratios are getting larger. That means something. My mother is texting me about the Dunning-Kruger effect. It sure is. If you don't know what that is, it's like, how do I explain it? Humans have a remarkable ability to think they know more than they do. So, if you're a noob in a concept, or a newbie in a concept, you'll think that you have the expertise of a master, basically. And the more you learn, you realize how much you don't know. So you kind of, it's a curve that starts low and goes up and then goes back down and then spikes up again. And the y-axis is like competence in the or eagerness of competence in the subject, I suppose. Like you'll be the actually guy if the higher you are up on that graph, and your x-axis is your level of expertise. So hopefully you'll be able to visualize it, or you could just look it up. That's probably faster. Funny thing is that the Dunning-Kruger effect is in itself a Dunning-Kruger effect. So there's layers to it. But that isn't mathematics. I'm in a rush. Is this something with it like converging absolutely? I don't know how to answer this one, so I wrote down my best guess. But, oh well, gotta move on. This one can be expressed by this. N equals 7. -1 to the nth power. 1 over ln of n. I don't know if there's any other subject that I could listen to absent-mindedly than mathematics, because we say the craziest shit, like, you know, ln of n, 1, -1 to the nth power. Like, yeah, if you don't know math, that just sounds like a whole bunch of bullshit. And if you listen to other subjects, you know, they'll talk about, you know, mitochondria as the powerhouse of the cell, cytoplasm, nucleus, etc. Like, those are words. I'm able to digest words. Like, I'm gonna pick up what's happening eventually. But math, it's just letters. It's letters and a whole bunch of bullshit, and it works. It works. Where did I put it? Here it is. I like how I say, where did I put it? And I'm talking about a YouTube video. We're funny. Humans are so funny. Okay. This one can be expressed as a series, which means that we can use the... Well, where did I put the actual paper now? Oh my goodness. Okay, there we go. The alternating series test, AST. converges by AST. Okay, next. Hey. This is literally the same problem that we dealt with earlier. That's pretty funny. Or, not the same problem. That would be boring. I mean, it's the same series, but we're answering a different question. It's obviously convergence or divergence, but this one has a -1 with to the nth power out front, which means that it will oscillate between negative and positive, which means some weird shit. Well, let's just try it with the AST. If this is less than or equal to n plus 9 and n plus 6. I'm not sure that's true. Infinity. My headphones. They always interrupt with low battery. Like, you know, when they get low. But it happens so often. It's like every time you plug it in, you unplug it, you tilt your head the wrong way, you boot up a new song every like 15 seconds. It's crazy. Moving on to number 4. Starting at n equals 8. That's interesting. I wish I was playing Elden Ring right now. Alas. This is... So we're supposed to be doing an alternating series test, but I solved this one with geometric. I wonder if that's okay. The logic works the same. It's just misplaced. My patience for this stuff is running thin. This will be pushing my limits. Gotta be strong. Oh my god, I forgot to write the number for this one. I'm so cooked. Number 5. N equals to -1 and e to the 8 over n. Wow. Okay, I see how it is. Unfortunately, I don't think that's geometric. That would be a good root test one, but I think I just have to use this. AST. So the second one is if the limit n goes to infinity of e to the 8 over n equals 0, which it does. Actually, wait. It doesn't equal 0, it equals 1. Oh no. Oh dearie me. So I need to use a different strategy. Oh, hey, you know what? That's very interesting. This is also a divergence test. series diverges by divergence test. I recognized that one of the tests we do in the alternating series test is the same as the divergence test, which means that if it equals 0, then you have your significance for the AST, but if it doesn't equal 0, you have your significance for the divergence test. So you get a result either way. Oh, I love that. Math is so cool sometimes. Actually, it's always cool. I'm so glad I understand it. Mostly. Equals 6. N cosine of n pi. I'm just going to write immediately that this is bounded. One thing about the yellow, it doesn't show up at all. Between -1 and +1. We'll save that for later. And then on the bottom, oh, I almost used a pen there. That would have been bad. On the bottom, we have 4 to the nth power. So, knowing that that is bounded between -1 and 1, we can kind of write that it's like this. We have n over 4 to the nth power. There we go. I'm doing a bad job of explaining this to you. I'm sorry. I mean, I suppose you don't need to. You're just a single brain cell organism on my desk. You don't mind that I can't explain stuff to you. You wouldn't care either way. I remember doing this stuff in class, but how did we justify it? Oh, we just wrote it like straight up like that. Okay, I'm happy with that. This would be that wouldn't work. Would it? Geometric doesn't work. What does? Divergence test. That would go to 0. Okay. We have n plus 1, 4 to the n plus 1 power is less than or equal to n to the 4 to the n power. Now, how do we go about this? Times 4. N plus 1 equals 4m. So we have 3n is greater than or equal to 1, which means that n is greater than or equal to 1/3. What does that mean? Oh, it means that when n is greater than or equal to 1/3, that's sufficient. Where do we go from here? Like 2. Limit n goes to infinity. This one should be simple. Of n 4 over n. We have 1 over ln 4 times 4 to the nth power, which definitely goes to 0, which is sufficient for the AST. Hooray! That's problem number 6. Now for number 7. Equals 9, negative 1 to the nth power. Oh my god. N to the nth power above n factorial. You disgust me. Although I can't help but think. Aha. Not quite. That was in section 3.5. I'm in 3.6. But it's the same question, so. as this recording is 1 hour and 51 minutes. Let's just try out the I thing. N plus 1 to the n plus 1 power, n plus 1 factorial is less than or equal to n to the nth power, n factorial. My oh my, that is disgusting. I can get it though. And to the nth power. So then we just subtract n plus 1 to the nth power, n to the nth power. Uh-oh. I don't think that's true. How would that be true? Maybe I need to take the ln of both sides, maybe. Ln of n plus 1 is less than or equal to n, or rather, ln of n. Is that ever the case? Ln n plus 1 is less than ln of n. I don't think that's possible. Because ln is an increasing function. It's never going to be the case. Inconclusive. I really want to use the root test against this. I know that this is 1, and all of these are greater than 1. So if all of them are greater than 1, that seems to mean that it diverges to me. Mm-hmm. All greater than 1. I know that it's divergent. It's just hard to prove. Suppose I could just write out my explanation, no? Let's see how that goes. Number 8. Absolutely convergent, conditionally convergent, or divergent. Oh, I'm going to stop this recording now because we're at the 2-hour mark, and I'll just pick up where I left off.